Hello and welcome to 6.3 using sec-x, cosec-x and cot-x. Now just a reminder, because this is key, we've got to know how to write sec-x in other forms. So that's going back to your sine, your cosine and tan. So sec-x is 1 over cos-x. Cosec-x is equal to 1 over sin x, and cot x equals 1 over tan x. So you need to know those before we go on and we start going through the examples from the textbook. So write those down to start with. So the first example, and we're going to look at A to start with. So I'm going to highlight that so that we can clearly see which one we're working on. And we want to simplify that. So to start with, if I write it out, that's equivalent to sine theta multiplied by cot theta. Well, cot theta, if you remember, is 1 over tan theta. So again, if you forget those, go back. It's these that you need. So you may want them on a piece of paper. You have got to learn them. You do know them, but have them there so you can keep referring back. And sec theta would be 1 over cos theta. Now, if I do some tidying up, because tan theta here, I could write that's the same as sine theta over cos theta. But because it's the reciprocal of tan theta, so this is the reciprocal of tan theta, that means that's equivalent to that. Because tan theta is sine theta over cos theta, but 1 over tan theta, or the reciprocal of tan theta, would be cos theta over sine theta, multiplied by 1 over cos theta. If I bring that all together using my fraction rules, I'll end up with sine theta multiplied by cos theta over sine theta multiplied by cos theta. If I'm honest, I wouldn't write the multiply in. I don't know why I did that. You'll notice now that the numerator is the same as the denominator, which means the answer is 1. So pause now, write that out, check that you understand every stage, rewind, listen. It's really important you fully understand that one and question it before we move on to part B. So now we're going to look at part B. There's part B. And it's the same thing again. We need to really know what the sine theta is. Sorry, not sine theta. We know what sine theta is, but what it is what is sec theta, what is cosec theta. So let me write my question out to start with. So that's the same as I'm going to leave the same. So sec theta. Well, sec theta, that's 1 over cos theta, add cosec theta, which is 1 over sine theta. Now here we need to add fractions. And when you add fractions, you need a common denominator. So this would become if you're not too sure what I've done there, because I want sine theta cos theta as my denominator. Don't know why I said that. So if you want sine theta cos theta as your denominator, I've multiplied my denominator here by sine theta, so I have to multiply my numerator, which gives me this. And here I have to multiply sine theta by cos theta, which means that if I multiply my denominator by cos theta, I have to multiply my numerator by cos theta. I now can put these together, and I'm only focusing on the brackets at the moment. So I can write sine theta plus cos theta all over sine theta cos theta, like that. Now you may notice that you are dividing by a sine theta cos theta and you are multiplying by a sine theta cos theta. So actually when we put these together, that I can divide the numerator by sine theta cos theta and the denominator by sine theta cos theta, and they would go because that divided by that would equal 1. So I would therefore be left with sine theta add cos theta, and that would be my answer. So now, again, pause. Go back through that slowly. Can you do it? Do you understand it? Do you see why I'm getting those answers? If not, come back, make sure you ask, watch that video, and then you can move on to C. So let's look at C. Prove. So this is a prove. Now, when you get one of these, I often see students make mistakes here with the proofs. What I would do, get a pencil. So here's my pencil, and cross out that side. By the way, you can prove right to left. They do allow you to do that. However, generally, left to right is easier. Okay. The reason I say cross it out is it stops you just being tempted to use it, because you can get halfway through and forget that. By crossing it out, it just reminds you when you get into the middle of a question not to go and pick it up. You'll think, why did I cross it out? So left hand side equals cot theta cosec theta over sec squared theta plus cosec squared theta. Now, this is where if your notation is not clear and it's not tidy, you are going to find that you are not going to get the correct answer. Generally, what I see here is lots of errors because of fractions, not because you don't do them, but because of your notation. So keep it tidy. Watch what I'm doing. So cot theta, that's, I'm going to open a bracket, 1 over tan theta, you'll see why in a moment, multiplied by cosec theta. Well, cosec theta is 1 over sine theta. And that's all of the numerator divided by, and so I've now got a fraction times a fraction within a fraction. Notice my notation. I don't have slanty lines here. That's where students so often go wrong, and why we say don't use slanty lines becomes even more of a problem when you start using these trig identities and differentiation, and you use something called the quotient rule. We see errors come in all the time, and students can do it, the work, but they make mistakes because of sloping fraction lines. Notice I don't use them. I don't use them because I don't want to fall into those mistakes. So now I'm going to look at my denominator. Sec squared theta, well, that's going to be 1 over cos squared theta plus cosec squared theta. Well, that would be 1 over sine squared theta. So this is going to be quite a long one, it's looking. What I'm going to do now is tidy up, focusing on my numerator. So 1 over tan theta, that's cos theta over sine theta multiplied by 1 over sine theta. And here I'm going to look for that common denominator idea. So I have now sine squared theta, and this would be sine squared theta cos squared theta multiplied, add, because I'm doing this bit here, by cos squared theta over sine squared theta cos squared theta. So just recapping there, I've changed tan into cos and sine here. And here I've come up with a common denominator. I've rewritten each of these fractions, so my common denominator is sine squared theta cos squared theta. Carrying on, now my numerator is going to become cos theta over sine squared theta because these are multiplying. So I'm using my multiplying fractions rules, cos theta over sine squared theta. There we go. Divided by, and this here would become sine squared theta plus cos squared theta over sine squared theta cos squared theta, like that. Wow, still going on. Now, what you need to have noticed here, which I shall highlight, is this is sine squared theta plus cos squared theta. And sine squared theta plus cos squared theta equals 1. That was something you learnt back in trig in year 1. So you can see now how this is becoming so much an A-level question. And for a long while, you maybe talk, what does an A-level question look like? Here we go, this is A-level. Because you've got that year 12 work, you're putting it with your year 13 work, and we're starting to get to something that's really challenging you. So we're going to take that and we're going to be able to rewrite this as 1. So what I'm going to do to make this easier, because I'm running out of paper, is I'm going to rewrite that last little bit up here. So this is a straight copy. I'll show you what I mean in a moment. So what I've done is I've copied this here, all of this just up here. Now I regularly do this. So you know when you turn a page in an exam booklet, I always do a straight copy. I never turn over the page and do workings. I just copy this bit over the page and do it again because it's very easy for me to check, have I got the right thing written down, which I have. So I now can carry on and I can go, okay, I can rewrite this now as cos theta over sine squared theta over, that becomes 1 sine squared theta cos squared theta, like that. Now this divided by this is fraction division, and I'm going to just write it like this. So I'm going to put in extra stages to stop me making silly mistakes. So I'm going to write that. So that's a division. And with fractions, I know that is exactly the same as me now writing this. Okay? I'm going to pause and say, look at the amount of workings I'm doing. It's a massive amount, and that's deliberate. I'm not going to lose marks because I miss out a line and I make a silly mistake, because that's where students lose marks. They try and do too many stages in one line. You look, I wrote that and I changed it to a divide and then I wrote it as a multiply. I know I can quite happily go from here to here. But in an exam situation, I never would, because I know I could make a mistake. And exams are about accuracy, and that's what they test. So I do this to make sure I get it right. Yeah, I can jump from there to there. And yes, if I was just doing it quickly, I would. But I'm not. I'm after getting full marks in an exam. I'm after trying to get myself that A, and that's what I need to do. I need to cut out the silly errors, which are regularly seen at this level. So I now do my straight multiplying across, and I'm going to get sine squared theta cos cubed theta over sine squared theta. Well, dividing my numerator, my denominator by sine squared theta, you can see I end up with cos cubed theta, which I've got there. It's cos 3 theta. Sorry, cos cube theta. I eventually got there, but look at all my work I've done to get there. Now, that equals the right-hand side, so I've proved it. So, that there was how you prove that question. You now need to have a go. Now, I would actually suggest, don't just copy what I've done, have a go. Actually write that down, see how far you get. And then when you get stuck, replay that bit of the video, get going again. So pause the video once you understand what to do, get going again, see how far you can get without having to keep looking at the video. It's really good practice. It's the way to learn. So that there is the proving and the simplifying style of questions. And now we look at the second type. So the second type are these where they're asking you to solve. And here we're looking at solving in degrees. So notice I've moved away from radians but we here are going to solve in degrees. So A, sec theta equals negative 2.5. So 1 over cos theta equals negative 2.5. So cos theta, if I rearrange, equals 1 over negative 2.5. So I now need my calculator. It's likely you've recently been doing radians, so make sure that you have it in the correct settings. Make sure you are in degrees, because if you're not in degrees, you are going to get the wrong answer. And as I said, that's another place we see as when we're marking exam papers as errors. So this 1 divided by negative 2.5 means that cos theta equals negative 0.4. So what does theta equal? So I'm going to use my calculator again because I want to find what that would be. I'm just typing it in now, and I get 113.6 degrees. That's degrees. Now I need to draw my graph out because it's the cos graph, and I wanted my answer between 0 and 360. So this is 90, this here is 270, this is going to be 113.6. Now, I've got another one of these here. Lots of different ways you can do this, by the way. To me, all the way to there is 113.6. So that was for 0 to 360. Sorry, for 0 from 113.6. So if I come back, can you see there's a symmetry there? So for me, the next value will be at 360 minus 113.6. You should be quite good at the symmetry of the graph now. If not, this is something definitely to practice because it just comes up more and more and more. So there we go. By the way, I'm writing these answers to 1dp here. However, in my calculator, I'm using the whole thing. Just be aware of that. So that's there. So they are my two answers for A, which, let me pull it back down, was sec theta equals negative 2.5. So again, have a go, make sure you got that down. This bit's the bit I'm most worried about. I think you'll be good at here. This is where I see students lose marks. Getting this out is fairly low grade, sort of C grade below, possibly, maybe even lower. It's here where you're starting to show that you're more than just a basic A-level student. You're the next bit up, okay? So pause it, have a go. I will then go on with B with you. So B. For part B, we're now looking for cot. We're now looking for cot 2 theta equals 0.6. Now remember, cot is 1 over tan 2 theta, which equals 0.6. So tan 2 theta would equal 1 over 0.6. So tan 2 theta equals, and again, this is where you just type it into your calculator, 1.666 recurring. So it's then 7. I'm keeping that stored in my calculator. Now, I've now got to find out what 2 theta is. Okay, so it's 2 theta I'm looking for. And 2 theta is tan to the minus 1 of that solution. So remember, when you're typing in, you're using that full answer from your calculator. So I get 2 theta equals 59.04. Now, I am going to only write my answers to 1 dp, but at this point here, I'm going to keep it to 2 dp because of the numbers that are coming up on my calculator. I now need to draw out my tan graph. When I was a A-level student, I didn't like tan graph. I've never understood why. It's the easiest graph ever. I don't think I ever appreciated it. So if you don't like tan, it is brilliant. It is easy. I've never appreciated it enough. And the reason it is, let me get my pen out, 59. So if this is 59, the next place that happens is here. Okay. And what you'll notice is this graph repeats every 180 degrees. So if you've got it there, it happens again here, which means that to find this here, you add on 180 degrees. So my next one would be, oh dear, I've just typed the wrong thing in on my calculator. Would be 239.04. Now, that's okay. I've done from 0 to 360, but remember, this is double angle. So actually, rather than going from 0 to 360, I've got to go from 0 to 720. So I still need to keep going. So the next one, because I'm going to divide them all by 2. Now, you more likely, or maybe I'm being unfair to you, have forgotten that you work out all the angles and then you divide by 2. You don't work one angle out and divide by 2. So that was something we learned back in year 12. So at this point here, we're writing all of the angles out. Then we divide by 2. So theta would equal 29.5 degrees. So that's my first answer, which is when I divide this one by 2. Then I need to divide the next one by 2, 119.5 degrees. Then the next one by 2, 209.5 degrees. And the last one, which is 599.04 divided by 2, which is 299.5 degrees. And they are my 4 answers. So just recapping, this is the one again. If I'm going to pick on where students go wrong, it's here. So work out what tan 2 theta is, work out what 2 theta is, and then work out all the angles for 2 theta, 1, 2, 3, 4. And because your range was 0 to 360, because you're going for double angle, it's now gone from 0 to 720. And then divide all of those by 2. Now, if you're worried about missing one out, you can just choose to go too far. So let's see what happens if I do that. So rather than stopping at 599.04, you can just add in extra ones. And I'm just working out the next one. So it'd be 779.04. If you wrote that down, the examiner will not penalise you. If you divide it by 2, you would get the answer of 389.5. If you then wrote that there, you would get penalised, but as long as you don't include it or you cross it out, that is right. So I am allowed it at this point, but I have to discredit it at this point. Personally, I would then go back and cross that one out. Okay? They don't generally penalise you here, they do here. So if you're still not quite getting this, where do I go to? Just do a few extra and then you'll know which ones to miss out because you'll just get values which are too big. Right, so that's everything about sec and cosec and cot and simplifying and simple solving and proving, and will allow you now to answer questions from exercise 6C of the Pearson textbook.